So we had some more stuff in fractions we need to do today that I didn't think about, we hadn't covered yet. So let's look at more on fractions. And let's go back to that pizza that we had 12 slices of. And let's say I didn't share this. I didn't share the pizza. I ate all 12 pieces. Or I ate 12 out of 12 pizzas. When we do the fraction, we are talking about the whole thing. When we do the individual slices, the numerator, we're just talking about the slices. Would I ever say I ate 12 out of 12 pieces? No. What would I say? I ate a whole pizza or I ate one pizza. 12 out of 12 is 1. And I'm glad you said whole pizza. This is a fraction. That is a whole number. Okay, so that's a question on the initial quiz. It's gonna say which ones of these are whole numbers, and it'll give you a fraction that's like written like this. I don't think it's 12 over 12, but it's some number. It's the number over itself. It's a whole number. It's 1. Let's take a look at something else. I want to motivate the ideas for multiplication and division. Let's say 4 of us each ate 3 slices. So how much total? How much of a pizza did we eat? We ate the whole thing, right? How do we get there from the idea of each of us eating it? We can add up how much we ate and find out. So I ate 3 12s, and Madison ate 3 12s, and Cody ate 3 12s, and Jerry ate 3 12s. And we know that when we do this, we looked at this before, when we have the same denominator, we can treat it as addition of the things on top. And that gives us our 12 over 12, which is 1. What you may not think about, but is very much fact, is repeated addition is multiplication. That's why we came up with multiplying. If I have to add 13 562 times, that's a really lot of adding. That's a pain in the ass. Multiplying 13 by 562 takes a lot less time, even by hand. So the way we write addition as multiplication is we look at the thing that's being added repeatedly, which is the 3 12s, and we look at how many times we're adding them. I have 1, 2, 3, 4 of them being added together. I can multiply this by 4. I should still end up with the same value, 12 over 12, which is 1. How can I get there from what we got? Do any of the numbers on the left have anything that might make us think that we could end up with this? I can see that I've already got 12 on bottom, so that's kind of like, that carries over. What do I got left? I've got a 4 and a 3, and I've got 12. How do I put 4 and 3 together to make 12? Multiply. So this is 4, 3 12s is the same as 4 times 3 over 12, which gets us the 12 over 12. That may not be immediately obvious to everyone. Another way of looking at the 4 is instead of writing 4, 4 is the same value as 4 over 1. So I can do 4 over 1 times 3 over 12. And now what we're going to do is multiply the bottoms together and multiply the tops together. And we end up with 12 over 12, which is 1. Wish I could kick that student out. I am pissed. And I can't in the future give everyone an extension about that person if I decide to do it again, because that's unfair treatment, but I really, really, really fucking want it. All right, so multiplying fractions is multiply fractions. Multiply tops together and bottoms together separately. There's a little more to it because the computer won't simplify for you. So let's take it a little bit more. Let's look at some more examples. Let's do 3 over 5 times 12 over 7. Before that, I want to go back and point out something I did at the very end. Notice we had 12 over 12 and I wrote it as 1. You always want to simplify too. That's important. So we can do this here. Multiply tops together and bottoms together. And we get 36 over 35. Now, I jumped ahead. I know there's nothing to simplify here. Ideally, the smart person checks to simplify before multiplying. Check to simplify, check for simplifying before multiplying. As you'll see in a second, it makes it a lot easier. I'll do that here real quick to show nothing cancels. 3, 5, and 7 are already prime numbers. When we can't simplify, we gotta cancel something on the top with something on the bottom that's equal. 12 is 4 times 3. This is 2 times 2 times 3. Nothing on top cancels with nothing on bottom, so it doesn't simplify. That's actually a done deal. We'll show it a little bit of another one that's a little easy, but we'll do it real quick. I can do 4 times 7 over 7 times 9. And things that show up on top and bottom with just multiplication only, I can cancel. And I'm left with 4 times 1, which is just 4, over 1 times 9, which is just 9. This is why sometimes when students cancel out, it gets in a habit, a lot of students, when they cancel out the numbers, they don't put a 1 afterwards, which is fine, so long as you remember, you cancel everything out, there's still a 1 left over. If everything on top cancels, it's not 0. There's always a 1 left. If I had multiplied out first, I would have had 28 over 63. And I can reduce, like, if I remember my times tables, I know these are both on the 7 row on the multiplication table. So that makes it kind of easier with that one to simplify, even if you've multiplied it out. But like the next one's a some bitch. And you're gonna be like, what? Say what? Let's do 20 over 42 times 35 over 16. If you do a calculator, that is 700 over 672. If I wanted to simplify that, I would have to go very fucking slow. I can recognize both of them are divisible by 2. I would start there, knock it down by 2s, then I would, till I can't do 2s anymore, then I would check for 3s, then I would check for 5s until I got to something I recognize as a multiplication. There's no way in hell I'm recognizing 672 is 42 times 16. But so, if we start from here, these are all things I know from the times table. I can write that as, and just go with the ones you recognize. If you recognize 20 is 4 times 5, put that down. 35 is 7 times 5. 42 is 6 times 7. 16 is 4 times 4. Now you can cancel out some stuff. You can see we've got a 7 on top and bottom, and we've got a 4 on top and bottom. If nothing canceled, I would take the prime numbers I had and write them down further. I'm going to do it anyways. The 6 goes down to a 2 times 3. This 4 goes down to a 2 times 2. I want to make sure it doesn't cancel with anything on the top, and it doesn't. I've only got 5s on top. So I've got 5 times 5 on top. And I've got 6 times 4 on bottom is, maybe I should write the 6 times 4 first. Then I could multiply that out and I get 25 over 24. That would be the actual answer that you want. That is what the calculator will give you if you do calculator fractions. If I do 20 fraction 42 multiplied by 35 fraction 16. What the fuck? Oh. Well, yeah, that fucking didn't even, This is showing me when I do it in a calculator, it shows that's the printout from the calculator. That means 1 and 1/24, which is not how the computer is going to let you enter the fraction. Although you shouldn't end up with a mixed fraction like that in stats. If they give you a problem, practice problem to do where it has that, you're better off doing this part by hand. The homework might also ask you, what is the unsimplified denominator? The calculator shows me a 24 is the denominator. It doesn't tell me that it would have been 672. So you got to make sure you know how to do some of this stuff. If you don't need to do it for the problem, don't do it. Use your calculator. If your calculator doesn't give you something that's handy to put in, then go and work with it by hand a little bit. The way you get from 1 and 1/24 to the 25/24 is this is the same thing as 1 plus 1/24. And I'm going to do this to the left because I ran out of room. I've got the 1/24, and instead of having the 1, I'm going to rewrite it as a whole number written as a fraction. So here, the 24/24 and the 1, that's what I'm doing. I'm replacing that because now I have, as we did on Thursday, we can do the denominator on bottom, 24 plus 1 on top, and we get the 25/24. So if your calculator gives you that and you're comfortable working backwards from a mixed number to a fraction, do so.
So you get that, did you multiply 1 to get 24 out of 24? Was it multiplication 1 times 24?
Yeah, I really multiply 1 by 24/24. Because 24/24 is 1. And so I can multiply times 24/24. You can always multiply by the equivalent of 1. Multiplying by 1 doesn't change a number's value. So this just gives us a way to write where the fractions are alike and we can combine them. Let me give you guys one to do. Is it? Anybody need this up longer? I see some pins moving. I might be rushing this. All right, let me give you guys one to do, and then we'll go over it together in class in a moment. All right. Anyone still working on it? If you are, I'll give you a little bit longer. I don't see anyone saying yes or raising their hands, so let's go forward. Let's see what we got. Let's see, I got 18, I know that's 2 times 9. 15 is 3 times 5. 25 is 5 times 5. 42 is 7 times 6. I can see right away 5s cancel. And even though I have 2 5s on top and 1 on bottom, they have to cancel in pairs. I can't cancel both 5s on bottom with 1 on top. I gotta go in pairs. And now I don't see anything else that cancels, but there is more stuff that can factor. And an intuitive eye will maybe even notice and not rewrite the factoring. I have a 2 and a 3 on top. 6 is 2 times 3. So it looks like the 2 and the 3 cancel with that 2 and the 3. Or you may have just said 2 times 3 is 6 and canceled the 6 there. Whichever speeds you up. You could have written each one of these different. You could have, if in hindsight, I should have done 18 as 3 times 6 rather than 2 times 9, and it would have gone right away. But the point is, you don't always recognize that. That would have been a better choice. I didn't do that, but I did now. I cleaned it up some more. And 9, I could simplify some more. 9 is 3 times 3, but that doesn't help me cancel out a 5 or a 7. So I have 3 times 3 is 9 on top. 5 times 7 on bottom is 35. And that's it. That's as simple as it gets. If I do that in my calculator, this one probably will do it just fine. Where did I fuck up? You're right, I did. There. I'm like, did I do it on the screen? Did I do it on paper? Did I say some stupid shit and no one said it? No, I calculated work, that's good. There is the advantage of doing it both ways. Then you can look and go, do they match? If they don't match, where did I fuck up? Because they better match. All right, so that was multiplication of fractions. Division of fractions. I'm going to do this as, I'm going to start off by going with 5 over 5 divided by 5 over 5. This is silly. No, let's make it 15 over 5 divided by 5 over 5. Let's do that. What is 15 over 5? If I divide 15 by 5? 3, right? And 5 divided by 5 is 1. And 3 divided by 1 is 3. There's another way to get this. This was not the good motivation that I wanted it to be. So instead, I'm going to do another one. Where's my pen? There it is. Let's take a look at dividing 2 divided by 1/3. We'll come back to this. Now, pictorially, what we do with division is we are taking something and dividing it up by that many pieces. So like if I had 2 whole pizzas and I wanted to divide it up in slices that were a third, so like a third of a slice on each of them, I could see this is 2 divided into 1/3. How many slices do I end up with? I end up with 1, 2, 3, 4, 5, 6. I have 6 slices. If I don't like doing division and I wanted to do something else, does it look like there's something I could do? Can I do anything with this? Without division? Using the same numbers? What could I do with these numbers here that where I could still get something that works? I could multiply the 2 by the 3, right? I could say 2 times 3 equals 6, right? That makes sense. That's exactly how division by fractions goes. What we do, this is really 3/1. The only reason I'm showing that is if we want, instead of division, multiply by the reciprocal. And I haven't said what the reciprocal is, but that's the reciprocal. What did I do to 1/3 to end up with 3/1? Like in normal, like, how would you describe that to someone else? Without math terminology.
You
What did I do
flipped
with the
it.
1/3? What?
You flipped it.
I flipped it. Reciprocal is flip it. So the reciprocal of 5/7 is 7/5. If I had, is everyone ready for more? So let's look at that 15/5 again real quick. Let me put it down real quick. Here I am dividing this fraction divided by this fraction. I have 15/5 divided by 5/5. Here, flipping it doesn't really change it much either. This is why I changed to a different thing, because I realized I wasn't gonna be able to show flipping it very well. If I flip it, it stays the same in this case. But I could make it multiply. And I see when I put them together, this is 3 times 5 times 5 over 5 times 5. And my 5's cancel, and I'm just left with 3. Oh, this is actually a great time to show it. When you cancel the 5's here, if you don't put the 1's, it's easy to look at this and say this is 3/0, right? Because I've crossed everything out on bottom. It's not really 3/0, it's 3/1. That was a 2-for lesson. I didn't do that earlier. I got cheated. Let me give you guys one to try. Oh, that's a better spot to put it. You guys ready? Anyone's, no, I see some pins still gone. Let me give you guys a little bit longer. Me and my wife are doing something fun this weekend. On Saturday, we were at our friend's yesterday playing like board games, had dinner there. And he said, hey, next week, you guys want to come over on Saturday night and do a paint night? They have, it's been popular for a while, where you can go out to like somewhere that serves wine. And they'll like, have a couple wines and they give you like a canvas with some paints and they give you an image to paint and they kind of talk about how to do it. I'm guessing most of you probably have never done it because you're young, but eventually at some point when you get older, you're like, that looks like some fun shit to do, an activity to drink and hang out with people. And we've done it a couple times, you pay to go do it. And they're like, we decided we're just gonna try it out. They went and bought easels, painting supplies, like some shit to lay around their office, and they found some videos on YouTube where you can have some like walk you through like a painting on YouTube. We're like, fuck it, let's do it. So that's what we're doing next Saturday. Everybody else will be drinking except me. I don't drink anymore. I have a bad habit of not stopping until I either run out or I black out. But those are not good options. Don't drink, it's a bad idea. All right, so I heard, okay. This is the same, I could have equivalently wrote this if I drew it in fraction form. The computer might show you some shit like that. But this is the same thing. If I want to rewrite it as multiplication, I have to flip that bad boy over. And now I'm going to do some factoring. 20 is 4 times 5. 16 is 4 times 4. 42 is 7 times 6. And 35 is 7 times 5. We did this earlier with the multiplying and not dividing. So some of this should look familiar. No, do we? Yeah, we did. Well, what cancels here? I see I got a 5 on top for both. And now I may be able to factor more, they're not prime numbers. 7 is already prime. The only number on bottom that isn't prime is the 6. I am going to factor the 6 as 2 times 3. And then I'm going to look to see up top if any of them have a 2 or a 3 in them. And they do. I can write one of these 4s as 2 times 2. If I do that, I can cross off a 2. And on top, I'm left with that 4. I'm left with that 4. I'm left with that 2. And on bottom, I'm left with the 7, the 3, and the 7. If you had bothered to factor out all the 4s, you could have written the top as 2 times 2 times 2 times 2 times 2. That's a 4, that's a 4, that's a 4. And then only canceled one of them. The reason why I mention this is tomorrow we are doing exponents. Just as when we had repeated addition is multiplication, repeated multiplication is exponents. Another way of doing this, as we'll see tomorrow, is 2 or 5, 2 to the 5th power. That's for tomorrow. But a little preemptive shot. If I multiply all this out, I end up with 16 times 2 is 32. And I did this on a calculator earlier. This is 147. And since I did all the factoring now, I know that is simplified. I don't need to look anymore. I don't know, looking at 147, that I would have busted out with 3 or 7 as a factor. So working with your factored numbers first, then multiplying when you've cleaned up is the better way to go. You guys ready for some more? I never asked you, Madison, so I'm going to ask you now. Do you go by Maddie or Madison?
Maddie.
Okay. I have a niece that her name's Madison. I call her Maddie all the time, and I started to call you Maddie earlier. I'm like, I don't know if she likes that. Maybe I better not do that until I ask. I try to be considerate. Try. All right, so that's enough of fractions. We will have more of it a little bit, but like that's all the operations with fractions. Let's talk about doing fractions to decimals. And we're going to start off real vague, well, real easy. What's $1 divided into 4 pieces? It's a quarter, right? It's 25 cents. If I do 1 divided by 4 in my calculator, I get 0.25. So this is just flat out division, and we've been saying that. We said that earlier. I'm just reminding you now. Divide the top by the bottom. Should get a decimal equivalent. Now, working with decimals is just like working with all your regular numbers. They're so much easier than working with fractions. Like in a calculator, you just add, multiply, subtract, or divide as you normally do. So decimal operations, decimal math, you should pretty much do it in a calculator. I'm expecting you to do it in a calculator. If you're doing it by hand, good for you. It's good practice, but you're gonna be like fucking tanking yourself when you do the midterm. You're gonna run out of time if you're doing shit by hand. So speed up wherever you can. We get, work smarter, not harder. So most of this stuff you're gonna do in a calculator. The issues students have in this class with decimals, let's see. There's two main issues that students have, or problem areas for students are in stats used with decimals are one, identifying the place value. And that always shows up in number 2, rounding a decimal. Those are the biggest areas that people make mistakes. And usually your math is right other than you rounding wrong. You'll go through the entire problem, you'll get the right answer, and then you'll round wrong. And the computer won't tell you, it really should tell you, you rounded wrong. And then you read the answer, you go, oh, okay, I can fix that. It doesn't, it just says, you're wrong. This is how you do it. And it'll start from step 1. And so you're like, I don't know what I'm doing. Well, no, most of the times, students knew what they were doing. They just rounded wrong. So let's address that today. Let's talk about the place value system and then rounding. Y'all ready? Let's just start with the big, fucked up number. 3,452.10796. And the reason why I'm doing the non-decimals, the left side, is because there's a pattern. And so let's split it up between what's on the left of the decimal and what's on the right of the decimal. The 2 is in the ones place. The 5 is in the tens place. Another way of thinking about it is 50 is the same thing as 5 tens. If you think about $50 and 5 $10 bills, you'll see that's right. So it's 5 tens. The 4 is in the hundreds place. And the 3 is in the thousands. And they start following a pattern. We start doing, the next number would be 10,000. And then 100,000. I fucked up the spelling right there, really bad. And then if you keep going, you have millions, 10 millions, 100 millions. You do this tens, hundreds things every 3 on the new category. Well, what happens when we go to the right? That was a lot of writing. Let me give you a chance to write that down, make sure everyone's on the same page. The 1 here is in the tens place. It doesn't start with 1s. The 0 there is in the hundreds, not tens, tenths. Fuck that up. The 0 is in the hundredths place. The 7 is in the thousandths place. You'll see that they follow the same naming scheme as everything after the 1 going the other direction. So the 9 is in the, what's after thousands? 10,000s. This is in the 10,000ths place. And the 6 is in the 100,000ths place. And I'm only writing 100,000ths like this because if I write the word 100, it's going to take up too much space. Earlier, I had one more decimal, and saying millions just sounded wrong. You very rarely see 6 decimal places. So the only difference between here and here is we don't have a 1th place. So there's no 1th place. And we add the TH after each one. You might wonder, where did this cockamamie naming scheme come up from? Why is there no 1th place? Let's take a look at what happens if I look at 0.1 as a fraction. This is 1 over 10. .01 is 1 over 100. So that's why we call that tenths. That's why we call that hundredths. In fact, as you saw here, there is a way to go from a terminating decimal or terminal decimal to a fraction. We will do that later today. I'd really rather knock out the rounding issue next. It's crazy that a lot of you only had like 1 or 2, maybe 3 things in common with me. My afternoon class was like 9 students that show up. A lot of them have like 10 or 11 things in common with me. They all like superhero shit. They all like watching shit like Big Bang Theory or some of the comedies on TV. A lot of them play video games. So the entire class, they just like instantly like bonded it, like I'm a mascot for them kind of thing. It's crazy. That class gets off track really quickly a lot. All right, you guys ready for more? I ramble a little bit. Oh, maybe before we start rounding, it's been an hour. Does anybody need a break? This is a good break point before we start rounding. Like if you gotta go to the bathroom, this is a great time. If not, we'll just keep chugging. I don't have to go. Anybody need to go? All right, let's keep going. That's awesome. All right. Guadalupe, you gotta go to the bathroom?
No, I'm good.
All right, I thought maybe I better ask you. Rounding. We're gonna start with a number and we'll just go through and do examples off of it. But I'm gonna give you the general rules first. That's the number we're gonna play with. For rounding, you do a couple things. For rounding to a specific decimal place. Look at the number to the right. Of it. If it is 4 or less, 0, 1, 2, 3, and 4, we are going to round down, which I'll show what that is in a second. And if it's 5 or more, 5, 6, 7, 8, 9, we are gonna round up. That morning class, I'm so still groggy in the morning, even though I had coffee. I forgot to tell my favorite story with this shit. I went to, you guys probably won't care, because you guys aren't gamers very much. I went to BlizzCon. Blizzard does like World of Warcraft, StarCraft, Diablo video games. They make a lot of video games. I went to BlizzCon, which is a convention. And I got tickets and I took like 5 or 6 of my friends. And one of the first things we did, we went to this, the game where you slide a puck along something and it slides over like sand and you try to get into an area on the other side. I can't fucking think of what that's called. There's a name for old people play it all the time. They have a bar. Shuffleboarding. So that's exactly it. You're too young to know that. They have it at bars too. So they had this shuffleboard thing where there was a target, bullseye, on the other side. And like you get the puck in the center and you get the grand prize, and then radiating outwards, it was lesser prizes, and you get one shot. And we went there straight first. We were the first ones in line. I went first. And I think I got like a medium prize or like a small prize. I missed. And so I'm standing next to the dude that's managed. I asked, what happens if you hit the line? Like you're over part of the, like in part of one ring, but not in the next ring. And he's like, okay, well, in that circumstance, I'll round up. Go for the better prize. My buddy gets up and he goes behind me and he slides it. And the puck is like 10% in the inner ring and the rest is in the outer ring. And I saw the dude fucking pause and I knew he wanted to give the medium prize. And I am standing right behind him. I went, round up, round up. And he fucking jumped. Fucking guy literally yelled it. Because we're in a convention, it's really loud. I want to make sure he heard me so he didn't screw my friend. Fuck it, but I wasn't thinking, oh, he's still this close. I don't really need you. Scared the shit out. He jumped, but he did round up. He gave him the best prize. That's fucking, has nothing to do with what we're doing right here, but it has the roundup phrase in it. All right, let's take a look at how we do this here. What rounding down, what rounding up means. Example A, let's round to the 1,000th place. So I will rewrite the number here and we'll take a look at it. you do not need to do what this, but I think it's helpful. When you're rounding something, figure out which place it is. The 1000th place is which number here? What? It's the 4. So I'm going to underline the place that I'm looking at, and then I'm going to point an arrow to the number at the right so I know what I'm looking at. So 5, that falls in the 5 or more category. So I'm going to round up. I said 5 of more here. 5 or more. There we go. When I round up, raise the number to 1 higher. And chop off the rest. The 0.23 are unaffected. They're before the round off position. The 4 goes up to a 5. So I'm going to replace the 4 with a 5. And I'm going to chop off the rest. I don't need them. So that will be the final answer on that one. This is one of the formats they will tell you how to round. They will tell you how the decimal place, its place value, and they'll say round to that place. That is one of the 2 methods they show for rounding. The other thing they show you is they just tell you how many decimal places to round to. They will say round to 2 decimal places or round a specific number of decimal places. We're going to do 2 decimal places right now. And I'm going to rewrite the number. When they tell you how many decimal places, this is handy because then you don't need to remember all the shit or even stop and think about it. 1, 2, I'm rounding to the 3. So I'm rounding to the 3. I look at the 4. The 4 is 4 or less. So I'm going to round down. I say round down, that's technically what we're doing. In all reality, what that ends up being is we leave the 4, we leave the 3 alone. Chop off the rest. So if I do that here, I leave the 3 alone, the 2 stays alone by itself. The 3 doesn't round, it stays as it is, and I get 0.23. And I want to point out something here. I'm going to do it on the next page. I want to make sure everyone's ready. You guys ready for the more? Notice we had, when I said round to the thousandths, we had round to the thousandths. and we got 0.235 here. And let's say I change my mind. I want 2 decimal places. I can see from over here, the correct answer or value is 0.23. From my original number around 2 decimal places, I get 0.23. What happens if I try to round the 0.235? I think I said the round in the wrong spot, but I round the 0.235 to 2 decimal places. What does this become? It becomes 0.24, right? The 3, the number next to the 3 is 5. 5 is in the 5 or more, it would round up. This is wrong. Don't try to round and don't try to re-round. Start over. This happened because the 4 went up to a 5. In fact, it's really the only time this mistake happens, is if you have a 4 and it elevates to a 5, you can fuck up on the next rounding. Usually, you're just fine. Whatever you rounded to would have been okay. There's one more example we need to point out with rounding. Let's say call this C. Let's say we had 0.1972 and we round to the hundredths place. Look what happens here. The hundredths place is the 9, and if I look at the 7, I see I gotta round up, which means the 9 turns into a 10. I can't, how do I put in 10? It's got 2 digits. I can't just put it in a single digits value. If I tried to replace it, if I just tried to replace the 9 with the 10, it would look like that. And that's a no. That's hands down a no. If we were looking at money, you would say this rounds up to 20 cents. This says 11 cents. They're nowhere near the same value. So this happens when it ends in a 9, when the position you're rounding is a 9. Grab the number to the left. And round. So I have the 0.1972. I'm going to do that here. I'm not just going to do the 9, I'm going to do the 19, and I look at the 7. 19 rounds up to 20. The next number up is 20, and I would replace the 19 with a 20. Which would be the correct answer here. You guys ready for some more? All right, so about that 0.20, I want to try to go through this real quickly. If we have 0.20 for the homework, like we just got from there, from rounding. Homework will definitely take 0.20 or usually 0.20. Usually you can drop the first zero. It might take 0.2 or 0.2. These are the same mathematical value. Are the same value. The reason why we show a zero at the end after rounding a 9, no, after rounding, period. If it has a 0 at the end, we leave it. It shows accuracy. .20 is accurate to the hundredths place. Point 2 is accurate to the tenths place. And it's good to, like, you're actually doing stats, and if you're publishing something that I want to see, you kind of want to show it. It lets them know. But like that, it really matters. Where this matters the most is in science. But the homework may take either one, because mathematically they're the same value. They just show a level of precision. Now, let's go back and look at those two categories we had. We had 4 or less, 0, 1, 2, 3, and 4. There's a couple other ways to write this. I could say that the number is less than 5. Or I can say, use this symbol, which is less, and I'll have to put a 4, less than or equal to 4. I didn't give that a lot of room. Let me move that over here like this. There's 2 ways to write that. So less than means all the numbers below it, but don't include that number. So all the numbers below 5 are 0, 1, 2, 3, and 4, and we don't include the 5. If it's got this little, this is like part of an equal sign, that line underneath, it means we got to include the number. So that's why I said this would be less than or equal to 4. The numbers less than 4 are 0, 1, 2, and 3. And then the 4 is the equal part. This little bit of like, either one you use doesn't really matter. I think less than 5 or more than 5. Less than 5 or 5 or more is the easier way to say it. When we get to like chapter, I don't know, 9 or 10 or some shit like that, there's a section where it really matters because you can't change the inequalities. These are called inequality signs. You can't change them in the software, so you need to know how to interpret them. We'll address that again when we get to it. The point is knowing what these signs mean. These are the where the thing opens to the right, it means less than. For the things that were more, 5 or more, where we had 5, 6, 7, 8, or 9, we can say that is greater than or equal to 5, or just greater than 4. So that's greater than, and that's greater than or equal to. They show this last symbol a couple ways, in the less than symbol too. You might see it where it's just flat out like that and then a line underneath it, kind of like I have here. Or you might see it where the bottom line is flat and looks like an equal sign with a thing on top. That's the same. Just different ways of writing the same thing. Some are easier than others to do, like for typewriters and shit like that. Well, I guess there is no greater than or equal to sign on the typewriter, but like when you're printing it in documents, stuff looks better certain ways. Why do you care? Well, these things, these symbols, is everyone ready for more? Actually, before I do that, I should have something right here. Like if I had 0.1, and this is 0.2, this would be like 0.15 right here. And the idea of rounding, like on a number line, is go to the closest value. So here I like say I'm going to go to the 10th spot. And I have 0.14. Which would be right here. The 2 tenths that are tenths positions around it are that one and that one. And if we look at how far away they are, it's closer to this one. That's kind of what's happening. If you like the number line, it works on the negative numbers as well. You won't be working with a lot of negative numbers in this class, other than shit they make you do on like the support course. It doesn't show up a lot in statistics. In fact, negative numbers in statistics is generally bad. It's bad juju. Now we talked about, I showed these symbols. These are called comparison operators. So this is like comparing numbers. So like, what if we had, how does 4 compare to 5? Four is less than 5. So I would use the less than symbol. If I switch that around, how does 5 compare to 4? Five is greater than 4. Now, if you treat this shit like an animal or like an alligator or let's say like a vampire, vampire always wants the bigger meal. I also happen to like looking at it like Pac-Man. A lot of you probably don't know Pac-Man, but if you saw like the movie Pixels, he shows up in the movie Pixel. That's like 8 or 9 years ago, but you guys are all old enough to have probably seen that, where the video games come to life and they're like attacking in the city or defending the city. So it's got Adam Sandler in it. Pac-Man walks around. It reminds me of that. I like going with a vampire because if I could become a vampire, I totally fucking would. The number of people I love, like, or really, really, truly care about, like, I wouldn't mind eating, let's say, is small. Most people, it's small. Usually it's all of your friends and some of your family. You don't really generally know when loves. Some people love everyone in their family. A lot of people have that asshole uncle or some shit like that. You're like, you're a jerk. You just don't like it. Friends, though, if you're a real friend, they're a friend. We're not talking about the guy that if you're running away from a bear, he would kick your leg out so that the bear gets you. That's not your friend. That's your acquaintance. It's someone you hang out with. But if push comes to shove, he's gonna let the bear eat you. The friend is like, helps you take out the bear or make sure if you fall, he grabs you and picks you up. That's your friend. There's a difference. Other than that, I could totally be a vampire. Would anybody else be a vampire? If you had the choice, would you be a vampire? No one? None of you? Then you would all be dinner. That's just disappointing.
I don't think I want to live forever.
It's like
I want to live a really, really, really long time, but you're right. I don't know about forever. I want to see who lives what. I want to live long enough to like see just how far humanity goes. Like, do we take over the solar system? Do we go outside the system? Do we like do outer space like some Star Wars and Star Trek shit? Do we do that? I don't know that I'm going to see that in this lifetime. Hopefully, we have like a moon base before I die. Or not a moon base or a base on Mars where I see like that. But I know if I was a vampire, I would see it. But then you could live too long, yeah. But then there's always like,
around to die.
what?
Like your loved ones, like you watch them grow old and die.
Or you turn them and they go get old, or they become a vampire with you. But if they don't want to turn, then you're stuck with a choice. Do I turn them against their will, or do I watch them die? I say turn them against their will, because under the assumption that like sunlight or like a stake through the heart still kills you, they can still die when they're ready to die. No, they'd be probably because you're stuck eating blood for a while. Like after that, you're eating blood, and they may not want you to do that. I don't know. I'd totally go vampire. Okay, that was to like take you off your mind off math for a little bit. Let's go back to some math. So that's how comparing those numbers work. How does comparing decimals work? So what we do here is start at the left and go right. Stopping when the decimal places do not match. Then compare those numbers. So here, the 0 matches up. The 0, those 2 zeros are the same value. Those 2 zeros are the same value. So like that right there, that right there, that right there. And then I get to the 4 and the 5 and they are different values. 4 is less than 5, so we use the same operator. 0.004 is less than 0.005. A lot of times that part doesn't really mess students up. Where students get got, that sounds funny. Where students make mistakes, there we go. Where students make mistakes is if we see something like this. Students oftentimes will, I don't know if it's a mistake or they just don't know rounding. They go 4 is less than 5, I'll put the less than symbol in. That's not how this shit works though. We really gotta go one at a time. Those pair up just fine. This 0 and this 0, those are the same. We keep going to the right. I get to the 4 and I get to this 0 right here. I'm comparing these two. 4 is greater than 0, so 0.04 is greater than 0.005. We have a bathroom in the same room, it's fucking crazy. Is that loud back in the back of the room? Could you hear the shit? Apparently not, you're like, huh? The clanking, the plumbing? Oh, hello. All right, something else that might pop up. How do I compare fractions? Switch to a decimal. So if I want to compare 7 over 9 and 8 over 11, If I throw this in a calculator, I get 0.7777, and it keeps going. Or I could do the repetition bar. Eight over 11 is 0.727272, blah, 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 blah. Or this is 0.72 repetition bar. Either way, once I've gone along, I can see that the second decimal, or the hundredths place, is where they differ. The 7, this 7 right here is larger than that too. So that number on the left's bigger, which means 7/9 is bigger than or greater than 8/11. Are we having fun yet? This is fucking exciting, isn't it? This is like go home and tell your relevant other, boyfriend, girlfriend, your dog, your mom, your dad, whoever it is. I had some exciting shit. We did some rounding today. We compared fractions today. It was great. You guys ready for more? Okay, so like, as I said earlier, decimal math, doing a calculator. Sometimes it's easier to do it by hand, it's quicker. Sometimes it's quicker by hand. Like if I want to do 0.02 times 0.4, the way you do it is you multiply the two numbers. 2 times 4 is 8. And then you count the number of decimal places. I've got 1, 2, 3 decimal places total. I need 3 decimal places total in my answer. In fact, doing this right away gets you to the answer this way. I'm going to show you what happens when I do this shit in my calculator. In the calculator, I get, it shows an X10 like this, really small, and that says -03. This I had not planned on teaching until maybe Wednesday, going over scientific notation, maybe even Thursday. This is called scientific notation. But if you don't know how to switch in your calculator, you need to know how to do it by hand. I didn't know how to do it by calculator until I was between classes. And I still think I'll probably fuck it up. What was it? I went through mode a few times and I hit 3 for normal, and then I said 2, and it shows it as a decimal. But like, it's hard to find and remember where it's at. So like, knowing how to work with scientific notation is really handy, because the calculator spits it out like this. So scientific notation, this value right here, this tells us how many times to move the decimal point. And which direction. Negative is to the left. Positive, or if it doesn't have a symbol, it's to the right. So let's go through that. If I have an 8, in fact, the calculator, if you look at it closely, it actually shows a decimal point right there after the 8. It shows a decimal there. That's the motherfucker we're moving. That's the decimal we're moving. So I have an 8 and the decimal's there, and I need to move it left 3 times because it says minus 03. Left 3 times. I put my new decimal over here, and anytime I moved an arrow but there was no number there, I'm going to fill in a 0. So 8 times 10 to the negative 3 becomes 0.008. If it's positive, we go to the right. And I fill in 2 zeros. I did 7 times 10 to the second power. I'm going to the right 2 times. I'll add in some zeros, and I put the decimal after it, and that becomes 700. So that's how scientific notation works. Why don't you guys try a couple and see what you get? 1.69 times 10 to the negative 4. And let's do 2.3 times 10 to the negative 2. Most of the time in this class, you will have negative ones. So you're moving to the left. Only in chapter 5 where you're like talking about the number of possible outcomes. And we'll talk about this in chapter 5 when you're doing those lecture videos. Like if you're looking at like how many different ways can I make a lottery ticket when it's like pick 6 numbers out of 75? How many different combinations are there? That's when you start getting like to the tens place. If you can't become a vampire, how would you choose to die if you could choose? There's a fun thought. I have a unique one. No one ever really says it. Most people look at it, I'm crazy. If I have to die, I want to be assassinated. Why? It's quick. Generally, don't fucking see it coming. and you're fucking important and famous, or at least important in the world. If you're not important, it's not called assassination, it's just called murder. Only important people are assassinated, right? So I've made a difference in the world. I've become important in the world, and I didn't see my death coming. Can you top that? No, you can't. So, everyone ready? There's my teacher's fucking crazy moment again. This says move the decimal left 4 times. So I've got the 1.69, I go 1, 2, 3, 4. I need to add in 3 zeros there. And I have 0.000169. Here it says -2, which means I need to move it left twice and put in a 0, and I get 0.023. Everyone good? Okay. Decimals to fractions and back again. Actually, it might be easier to go fractions to decimals first. Let's start with there. If I had 63 over 100, I get 0.63. If I have 1 over 16, fuck it, let's go 9 over 16. Let's be crazy. .5625. That's pretty easy. Some of them are even easier. When you divide by a multiple of 10, or anything 1 followed by zeros, like I did on the left with the 63, I can count the zeros after the 1 on bottom and move the decimal left that many times. For example, 457 divided by 10,000. I have 4 zeros here. So I'm going to move the decimal 4 decimal places. So it's going to go pop, 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 pop. And I need to add another 0 in front. This becomes 0.0457. While we're talking about multiples of 10, I switch which cap is on which. Fail. Multiplying by a power of 10 multiple of 10. Count the zeros and go right that many times. For the decimal place. So let's say I had 0.00345 and I multiply it by 1,000. I have 3 zeros right here. So I'm going to move the decimal place, move 3 times. And this will become 3.45. No calculator needed. Anything with a 1 followed by zeros follows this pattern. This is really what scientific notation is doing. And I'll mention that again when we hit scientific notation. What about going the other way, decimals to fractions? Before I turn the page, maybe I should make sure everyone's ready. Everyone good? Okay. So decimals to fractions. There are situations for the non-terminating numbers. If you recognize it, you can do it. But this is usually for terminal or terminating decimals. Which means they end. What you want to do is you want to count the decimal places. Let's say that's a value D. I don't know what it is, but however many it is, it's D. Part 2 is you are going to make a fraction where the top is the decimal number without the decimal point. And the bottom is a 1 followed by D zeros. Whatever you got from the first thing. So let's take a look at an example. Let's say we have Almost sneezed, that's always great. Let's say we have, let's do 67 over 10,000. Wait, fuck, I started with a fraction there. I wanted to start with a decimal. All right, let me pick a different number. Let's do 159, oh, fucking did it again. Let's go 0.000159. There we go. Let's do that. Keep trying to start with a fraction. It's fucking crazy. Okay, so how many decimal places do I have? I've got 6, so my D is 6. So what I'm going to do is I'm going to take the number and put it on top without a decimal. And on bottom, I'm going to put a 1 followed by 6 zeros here. I'll put some commas in there so it's a little bit more readable. And I wouldn't leave the zeros in front. This becomes 159 over 1 million. I think that's as simplified as it goes. It didn't look like it cleaned up any. Huh. Yeah, that's a prime number on top. If we look back though, we had nine over 16 was 0.5625. If I follow those rules right here, I've got 4 decimal places. So I want 4 zeros. And I will have 5,625 over 10000 or 10,000. The computer is gonna want this. If you start with the decimal and it says convert to a fraction, it wants that. You get this. Now, maybe one of your calculators will show it and do that for you. Mine does. Mine simplifies to 9 over 16. If yours doesn't, you gotta do it by hand. I want to make sure everyone's ready before I turn the page. Everyone good? Some of you are probably bored because you already had this thing completely done, and like the next chapter too. By Sunday, I think, yeah, you were one of them, Maddie, weren't you? You know the homework on that? Yeah, you're just sitting there bored. Okay, so 5625 over 10,000. You just got to go through and look for the prime number, divide by prime number, see what goes away. 5625 doesn't divide by 2, that's out. We're checking numbers like this. 10 only divide, or the 10,000, this is 10 to the 4th power. It's only got 2s and 5s in it. That's what we're looking for in top. Only looking for 2s and 5s. Which means we don't have to check all the prime numbers, we just gotta check 2s and 5s. It's not, this number is not divisible by a 2, but it is divisible by 5. So keep dividing by 5. 5625 over 10,000, we do divided by 5 on top and bottom. Top is 1,125, the bottom is 2,000. Looks like we can divide again. I get 225 over 400. I can divide it again. I get 45 over 80. And if I divide by 5s again, I get 9 over 16. You guys ready for some more? Percents. Decimal to a percent. What we are effectively doing is multiplying the number by 100%. So if I start off with 0.637, and I multiply it by 100%. Those rules of multiplying by powers of 10 work here. I see 2 zeros. I can move the decimal point 2 times. And I get 63.7. And then I just got to make sure I put the percent down. So 0.637 is the same thing as 63.7%. If you don't want to do that multiply by 100 thing, you just got to remember 2 rules. A, move decimal point right twice. B, add percent symbol. If you want to go the other way, percent to decimal. Reverse this. It's kind of like dividing by 100%, but it's easy to reverse it. A, drop the percent. B, move the decimal point left twice. So if I have 8.25%, I'm going to cross off the decimal or the percentage sign, and I'm going to move the decimal point left twice. and I get 0.0825. These are equal in value. The reason why we do two different things is if I told you sales tax was 0.0825, you would all look at me like I'm fucking crazy. If I say sales tax is 8.25%, that makes more sense. When we talk about things in words, we tend to use the percentages. But the percentage is not what you use when you're actually calculating sales tax. You're using the decimal. So the decimal is what we use in math. The percent tends to be what we say with it. They are interchangeable. Any questions? Let's see, what did I do earlier? I want to make sure I hit that topic well. Yeah, I did. Well, if you don't have any questions, fuck out. We're good. You have any questions, Guadalupe?
No, I don't. Thank you.
Okay. Have a good day, and I will see you guys tomorrow.